Greetings everybody to example 5 of polar coordinates. So in this problem, what we're asked to do is to find the arc length of the curve given by r is equal to e to the 2/3 theta over the interval 0 to pi, and we want to find the arc length rounded to 3 decimal places. So let's jump in and see how we can do this. Well, one thing that we can remember is that our coordinates transformation to just polar coordinates is just given by r cosine of theta, y being r sine of theta. So in this case, when we have the r as a function of theta, this just gives us e to the 2/3 theta times cosine and e to the 2/3 theta times sine. Now, stopping to remember what our arc length differential form was, our ds was going to be the square root of the square of dx d theta squared and dy d theta squared d theta. So taking x to be e to the 2/3 theta cosine of theta, what we then have is for dx d theta to be our e to the 2/3 theta cosine of theta times 2/3 plus, or rather minus, e to the 2/3 theta times sine of theta. And then likewise for dy d theta, we have a 2/3 e to the 2/3 theta sine of theta plus e to the 2/3 theta cosine of theta. So now we can just take this and plug it into our arc length form, and let's see what we have. So we can take our derivatives and plug them into part of our differential form. So now we can just expand everything and square. So we have an e to the 2/3 theta in each one of those terms, so we can factor that out. And so that's going to give us, when we square it, an e to the 4/3 theta. And then squaring the inside terms, we have a 4/9 cosine squared minus a 4/3 sine of theta cosine of theta plus a sine squared of theta. And then likewise for the second term, we can factor out again an e to the 2/3 theta, so we have e to the 4/3 theta times, on the inside, we have a 4/9 sine squared plus a 4/3 sine of theta cosine of theta plus a cosine squared of theta. So now again, factoring out that e to the 4/3 theta from both of those terms, what happens is our 4/9 cosine squared plus our 4/9 sine squared, those will combine to just give us a 4/9. A minus 4/3 sine cosine plus 4/3 sine cosine, those terms will cancel out, and then our sine squared plus our cosine squared just gives us 1. So what we then have for our quantity dx squared plus our dy d theta squared just gives us 13/9 times e to the 4/3 theta. So that our ds will then just be the square root of this, so we get the square root of 13/3 e to the 2/3 theta d theta. Now we're ready to actually do our arc length. So for an arc length form S, we have just the integral over our curve of ds. And so in this case, this is going to be the integral from 0 up to pi, and then we have the square root of 13/3 and e to our 2/3 theta d theta. So that just doing this integration, we have root 13/3, then we have a 3/2 e to the 2/3 theta evaluated between 0 and pi. And so what happens in this case? We get a value of root 13/2 e to the 2 pi over 3 And then when we plug in 0, we just have 1. And so there we have, as our final answer, root 13 over 2 times the quantity e to the 2/3 minus 1. Which, if we then plug that into our calculator, will give us something that approximately is 12.836713332. So I hope you've enjoyed this example, and I will see you guys in the next one. Take care.